Exercise 14.2. Question number 1. Solve for x and y by substitution method. Substitution method is a method in which we uh, replace the value of one variable got from one equation into the other. For example, in part A of question number 1, you see we need to have if the value of the variable y is x plus 3 from equation number 2, we are going to substitute this value in equation number 1. So, substituting y is equal to x plus 3 in equation number 1. What do we get? At the place of y plus x is equal to 7, we need to replace the value of y, that is x plus 3. This is the value of y we have got from the second equation, and then plus x is equal to 7. Now the like terms are x, and then shifting this 3 to the other side, that will give me 4. The value of x is 2. Once we have got the value of one of the variables, we need to resubstitute this value into the other equation. So substituting in equation number 2, that is y is equal to x plus 3, that is 2 plus 3, y is equal to 5. So this is how we get the values of both the variables. So we can write down like x, y as x is 2 and y is 5. So this is the answer to part A. Now, in the same way, uh, we can have, for example, from part E, if I solve it, you see, we can first of all rearrange equation number 2 to have the value of variable y. This is part E now, and I write from equation 2. 2x minus y is equal to -8. We need to see, we need to have the value of that variable which has got coefficient as 1, as y has got coefficient 1. So we would be making y as a subject. So let me shift this y to the other side. So this will give me 2x plus 8. This is the value of the variable y from second equation. Now I substitute it in equation number 1. And that will give me 3 times x minus 2 is equal to -2y. At the place of this y, I'm going to replace 2x plus 8, and then -2 is being multiplied with it, and the rest of the whole equation would remain unchanged. So this will give me 3x minus 2 is equal to -4x, -16. Then 3x plus 4x, shifting this here, and -2 to the other side, -6 plus 2. 7x is equal to -14. So the value of x is -14 by 7, that is -2. Once we have got this value of the variable x, now we will be substituting in this equation. to have the value of the other variable y. 2x plus 8, that will give me 2 times negative 2 plus 8, negative 4 plus 8, that is positive 4 only. And the value of the variable xy is, x is negative 2 and y is 4. Okay, once we have got these answers for these simultaneous linear equations, uh, we can check them out whether our answer is correct or not. So the method is, though it is not the requirement of the question, so we can just see it. We can replace this value in either of the two equations. If I replace this value in, let's suppose, equation number 2, that states that y is equal to x plus 3. Now, if the value of x is really 2, let's see whether the value of y really is at 5 or not. So 2 plus 3, that is 5. Yes, the value of y is also compatible with our answer. So that means our answer is correct. Similarly, if we can check this one out as well. And it is not necessary that we need to replace the value in uh, which of the equations. We can replace this value in any of the two equations. So I'm going to replace, let me replace it in equation number 2. 2 times x minus y. 2 times the value of x is negative 2 and the value of y is 4. That is negative 4 minus 4. That is negative 8. Yes, which is equal to the right hand side of the given equation. So our answer is correct. So that is how we need to check our answers. And these answers that we have got, these actually give us the point of intersection of these two lines. When we will be drawing the graph of this one as well as the graph of the other equation, the point where those lines are going to intersect, that would be the point of intersection represented by our solution answer. Like if n one line is this one, other line is this one. So the point where these lines are going to intersect, that is represented by the solution of these simultaneous linear equations. Okay. Uh, in part H, if you can see, we do not find any variable with coefficient 1. So one thing that we need to observe is we can, in this case, have the value of either equations from either of these equations of either of the variable. So 3x minus 4y equals to 1. Let me have the value of x from here. That will be positive 4y plus 1 whole divided by 3. Now this value of x may be replaced or substituted in the other equation. Substituting in equation number 2. 2x is equal to 4 minus 3y. 2 and the value of x that we have got, that is 4y minus 1 divided by 3 equals to 4 minus 3y. You see, 4 minus 3y. 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 4 min in this equation, the variable x has been eliminated, it has vanished. So when we will be solving it out, we will be getting the value of the variable y. So 2 times 4y, that will give me 8y minus 2, and shifting this 3 to the other side and getting it cross multiplied, I get 12 minus 9y. So 8y plus 9y is equal to 12 plus 2. The value of variable y is 14 by 17. Now we can replace this value of the variable y into this relation that we have got for the value of x, 4, and then the value of the variable y, that is 14 divided by 17 plus 1 divided by 3. So this will give me, that is, this is the value of variable x, and the value of the variable y is this one. So this is how we need to solve these simultaneous linear equations by the method of substitution. For checking purpose, let's check it out whether the answer that we have calculated is correct or not. Let me replace it in equation number 1. 3 times x minus 4 times y. We need to see or check whether the answer is equal to 1 or not. 9. So this can be done as 51 as the LCM. So this is 219 minus 168. That is 51 divided by 51. That can be cancelled out. So the answer is 1. Yes, equal to the right hand side of this. So that means our answer is correct. So this is how we solve them. Now this is question number 2. Solve x and y by elimination. Elimination is a method in which one of the variables used in the equations get vanished. It is being eliminated from these two. Okay, now you observe we choose that variable in which the coefficients are the same of the variable. You see the coefficient is same for variable y. So we will be eliminating this. If you observe this one, in this, the coefficients of the variable x are same except for the sign. So we would be eliminating this variable x easily. Though we can also eliminate the other variable as well, but it would be more easy to eliminate that variable which has got the same coefficient. Now for question number 2, part A. For eliminating variable y, which is having the same coefficient in both the equations, we need to observe one more thing, is that in one equation, the variable y has got sign with a negative, and the other one, it has got positive sign. So when the signs are different, we add them. And when the signs are same, we subtract both the equations. So let me write down adding equation number 1 and equation number 2. I'll be getting 2x minus y is equal to 4, and then 5x plus y is equal to 24. So when we will be adding them, uh, negative y and positive y will get cancelled out, and 2x plus 5x, that will give me 7x, and 4 plus 24, that will give me 28. Now you see the variable y has been eliminated from the whole scenario. So the value of x will be 28 divided by 7, that is 4. Once we have got the value of one of the variables, we can substitute that value in either of the equations. So let me replace in equation number 1. That seems a bit simpler with smaller coefficients. 4 is lesser than 24, and then 2x is lesser than 5x. So that's why it would be more easy for me to solve it out. So 2 times x, the value of x is 4, minus y is equal to 4. 8 minus y is equal to 4. So 8 minus 4 is equal to y. That is 4. The value of y is 4. So the answer is xy is equal to 4, 4. And if we need to again check them up, we can check it out by replacing this value of x and y in either of these two equations. Let me put it in equation number 2, for example. Okay, 5 times x, the value of x is 4, then y, the value of y is 4, 20 plus 4, that is equal to 24. Yes, equals to the right hand side of the given equation. So that is how we solve them. Okay, now for part B, for example, you see their coefficients are the same with opposite signs. So we again would be adding them up. Instead of part B, if I do part C, now I will be subtracting them. Subtracting these two equations, 2x plus 5y is equal to 12, and then 2x plus 3y is equal to 8. When we subtract them up, in case of subtraction, the signs of all the terms of the equation which is being subtracted, the signs get changed. This will become negative 2x, this will become negative 3y, and this will become negative 8 now. Now we can easily cancel them up. Positive 2x get cancelled out with negative 2x and 5y minus 3y. This will give me 2y, and on the right side, it is 12 minus 8, that is 4. So the value of y is 4 divided by 2, which is 2. Once we have got the value of one of the variables, now we can replace this value in either of the two equations, replacing in 2x plus 3y is equal to 8. 2 times the value of the variable y is 2. Then 2x plus 6 and 8 minus 6, that is 2 divided by 2. The value of x is 1. So the final answer is xy is equal to 1, 2. And for checking, again, let me check it out also. It is not the requirement of the question normally, but here we need to check it out, check each solution. So I'm choosing the second equation, 2x plus 3y. 2 times the value of x is 1 and the value of y is 2. We get 2 plus 6, that is equal to 8. Yes, as is the right hand side of the given equation. So this is how we solve these questions. Okay, now this is not necessary all the times that if you observe in this question, we are given with the equations in which the variable which is to be eliminated has got the same coefficients. This one, this is one, same coefficients. In this case, the coefficients of x are same, and so on. It is not necessary to have the same coefficients in all the cases. So how do we solve them up then? In question number 3, for example, we can see if I need to solve them up, solve simultaneously, use the method you find easiest. If I multiply this second equation with 3, so I'll be getting 30x minus 3y is equal to 48. Now, the first equation remains the same, 5x plus 3y equals to 22. Now you see 3y and negative 3y. Now this is the same thing. In this case, what we have done, we have multiplied the second equation by 3 so that the variables y have got the same coefficients with them. So having different signs, we now need to add them up. By adding positive 3y and negative 3y will get cancelled out, and this will give me 35x, and on the right side, this is 70 divided by 35. The value of x is 2. Once we have got the value of one of the variables, again we can replace this value in either of the equations. I can replace it in equation number 1. So that will be 5 times x, that is 2, plus 3 times y, that is equal to 22. So 3y is equal to 22 minus 10, that is 12 divided by 3, 4. So the answer is x comma y, that is 2, 4. Now for checking purpose, we can replace this pair of values in equation number A. Let me do it. 5 times x is 2 plus 3 times y, that is 4. 10 plus 12, that is 22. And yes, that is compatible. So this is how we need to solve them. Now in whole of the parts in question number 3, we will be finding any one variable with coefficient 1, like here, like here, and so on. So in that case, it would become easy if I can multiply this whole equation with 4, so that I can get 4x as the other equation. In this case, I need to multiply this equation by 5, which is the coefficient of y in the other equation, to have the equal coefficients. So I will be getting negative 15x plus 5y is equal to 25, and the other equation remains unchanged. So now we can again subtract them, because uh, their signs are the same, so we need to subtract them. When we subtract, I told you that the signs of all the terms of the second equation which is being subtracted, that get changed. So positive 5y and negative 5y will get cancelled out, and negative 15 plus 6, that is negative 9x, and this is 25 plus 20, 45. So the value of x is negative 5. Now replacing it in equation number 1. So I get negative 3 times x, that is negative 5, plus y is equal to 5. So 15 plus y is equal to 5. So the value of y is 5 minus 15, that is negative 10. So x comma y is negative 5, negative 10. And now the checking purpose, let me solve it in equation number 2. Okay. Negatives, though it would be easy to check it for equation number 1, but let me solve it for equation number 2. Times the value of x is negative 5 plus 5, then the value of y is negative 10. We get positive 30 and then negative 50. That will be equal to negative 20, which is equal to the right hand side of the given equation. So this is how we need to solve them up. Okay. Now in question number 4, all the parts of question number 3 would be similar. So I'm just going to solve question number 4. Now we see that neither of the variables is having coefficient as 1. So now the procedure is, choose the variable that you need to eliminate. Let me choose variable x to be eliminated. Okay. Then what would I do? I would be equating the coefficients of variable x in both the equations. Then the procedure is that we need to multiply the first equation with the coefficient of with variable x in the other equation, that is 5 in this case, and then I will be multiplying the other equation with the coefficient of the variable x in the other equation, that is 3. So this is how it is to be done. So 5 times 3x plus 7y is equal to 37, which will give me 15x plus, and then 185. Then for the other equation, this is 15x plus 18y, and then so this is how we do. Now you see the coefficients of the variable x are same in both of the equations and having the same signs, positive and positive. So now we need to subtract. When I'm subtracting it up, the signs of all the terms of the equation that is being subtracted get changed. So positive 15x and negative 15x get cancelled out. 35 minus 18. And this will give me So the value of y is 68 divided by 17, which is 4. So the value of y is 4. Once we have got the value of one of the variables, so we can substitute. Let me substitute it in equation number 1. 3x plus 7y. Y is 4 is equal to 37. So 3x, 7 for the 28. 37 minus 28. 9 divided by 3. The value of x is 3. So our answer is xy, that is 3, 4. And now the check purpose, let me replace it in equation number 2. 5 times x, that is 3, plus 6 times y, that is 4. So that will give me 15 plus 39. Yes, that is equal to the right hand side of the equation number 2. So this is how we solve them up. And rest of the parts are the same. Let me choose part K, for example, to solve it out. We can use the substitution method as well in this part. So let me use that one. When I'll be having the value of y, negative y is this. So the value of positive y, that is going to be negative 3x, negative 11. That is the value of y. I've multiplied this whole with negative 1. So replacing this value into the other equation, negative 2x plus y. The value of y from the other equation is negative 3x, negative 11. And then on the right side, it is 4. So negative 2 and negative 3, that is negative 5x. And then 4 plus 11, that is 15 divided by negative 5. The value of x is negative 3. And replacing now this value into this relation, the value of y is negative 3 times negative 3 minus 11, positive 9 minus 11, so negative 2. So our answer is x comma y, that is negative 3 and negative 2. And now finally the check purpose. Let me replace it in the second equation. Negative 2, x is negative 3, and then plus y, which is negative 2. So 6 minus 2, that is equal to 4. And yes, the answer is compatible. So this is how we need to solve simultaneous linear equations. So I hope it would be clear.